Hello everyone, my name is Mattia Chiari and I'm a PhD student at Università degli Studi di Brescia. Today I'm going to present length of stay prediction for Northern Italy COVID-19 patients based on lab tests and X-ray data. In March 2020, we started our collaboration with Ospedali Civili di Brescia, one of the hospitals that unfortunately had more COVID-19 patients in Italy. Our system is designed to predict the length of stay for patients at different times during their hospitalization. To do this prediction, we use machine learning models that are trained with over 1,000 patients' data. This work can be particularly useful because by knowing in advance the length of stay or other adverse events, we can help the hospital in organizing the allocation of limited resources in a more efficient way. As said, we want to predict the prognosis at a different time during the hospitalization of a patient. To do so, we take a snapshot of the patient condition, considering the most recent lab tests in a particular moment. We decided to predict the prognosis after 2, 4, 6, and 8 days after the beginning of the hospitalization. By using the snapshot datasets, we may have some outdated values for our lab tests. To let our model recognize these outdated values, we also included the aging feature for each lab test. This feature is the number of days that passed since the test was taken. We also decided to include two trend features, one long and one short, to represent the evolution of the patient conditions. To evaluate the performance of our models, we selected mean absolute error as metric. Random forest regressor and extra tree regressor gave us the best performances, and this is also in accordance with our previous work results. To optimize our models, we performed the hyperparameter tuning using random search with tenfold cross-validation and using both mean absolute error and root mean square error as metrics. In this table are reported our results. We have the overall mean absolute error and the mean absolute error for patients who stay from 0 to 7, from 7 to 14, and more than 14 days. We can see that the overall error is always between 4 and 5 days, which is quite promising. And in the last column, we can also see that predicting the exact length of stay for patients who stay in hospital for more than 2 weeks after just a few days of hospitalization is a very complex task. In fact, we get more than 7 days error for all our datasets. The best result is obtained after 8 days, mainly because after this amount of time, the model can exploit more data for giving the prediction. Although mean absolute error is a good overall estimate for our models, this value can also be misleading. In fact, it gives the same results for predicting 2 instead of 7 and for predicting 20 instead of 25, which in length of stay prediction are two very different results. For this reason, we also consider how the system identifies patients who stay for a longer period of time, which, according to length of stay distribution, we decided to be 16 days. The identification is considered correct if both the prediction and the growth rate are above or under threshold. Here we have the confusion matrices for our test set, and we can see in the first column that we have some issues for not recognizing patients with length of stay over the threshold for 2 and 4 days with respectively 31 and 27 error. However, the errors decrease in the 6 and 8 days datasets with 22 and 15 error. On the other hand, we can say that when our system predicts that a patient will stay more than 2 weeks, its prediction is very reliable. We have presented a system for predicting the prognosis of COVID-19 patients, focusing on the length of stay. The overall mean absolute error is always less than 5 days, and in particular, we obtain the best result for those patients who stay in hospital for a shorter period of time. For our future work, we are currently analyzing the importance of the features used in our models, and hopefully we plan to extend our datasets with more information. Thank you for listening.